Welcome to this technical demo session on harnessing the power of Azure Cloud builds from development to deployment. My name is Zilin, a program manager at Microsoft focused on Azure for game development. Now, this is a follow-on session to my main talk of the same title, so if you haven't already, please go ahead and watch that for the full context of this demo. Please enjoy the demo.
What we'll see in this session is a basic example of how a studio that's working remotely around the world might use Azure to centralize their game production workflow. On this diagram, the big boxes represent separate Azure regions where studio staff might be spread across. To the left and right are developers using virtual desktop infrastructure to work directly in Azure through GPU-powered VMs. And at the heart of it all is Perforce Helix Core for version control and Azure DevOps, our SaaS CI/CD solution. This fictitious studio is taking advantage of the fact that their workflow, data, and distribution are all centralized within Azure. At this point, let's see what this whole in-cloud workflow looks like with a quick demo. Let's take an example of a day in the life of a studio where we have a game in development represented by a commonly used sample Unreal Engine 4 project. Let's see how changes a designer makes in the game would flow through Perforce and the CI/CD pipeline, all in Azure. We'll shrink that diagram into a mini-map up to the top right of the screen to keep track of progress. Now, starting from that designer who's working from home in one Azure region, this is their desktop logged in remotely through Parsec. They're already logged into Perforce using single sign-on, which makes it pretty seamless for them. They then sync to the latest revision of the dev branch and call up the Unreal editor to make a couple of simple changes that the producer wanted to the holoboards. Then a quick in-editor test to make sure everything looks all right. Great, and now the assets are saved and checked into the main depot right in Unreal Editor. And of course, the necessary change list comments are put in place. We slide a little over to the right as the Perforce depot has a trigger that fires on changes to that dev branch and makes a REST call to Azure DevOps to start a build pipeline. Now you're looking at the web interface of Azure DevOps. These sequences are full end-to-end captures, but are all sped up so we can see a full build run. This pipeline has a single job with multiple tasks labeled on the left columns. The pipeline first syncs to the head of that dev branch. Then the next task is to actually build the game. And here we're using a PowerShell script to kick off the Unreal automation tool to do this. Now all this pipeline work takes place in build agents, which are either Azure VMs or on-prem machines that you can configure to take this role. So let's open a remote desktop session to see what's happening in the build agent. There we go, the build agent VM is set up with all the packages needed to build this game. And we can also see that Incredibuild is installed and the build monitor shows that compilation is proceeding as we expect. The Incredibuild coordinator has automatically scaled up VMs in an Azure VM scale set to accelerate this build. And in the build monitor, towards the middle of the screen, you can see work being spread out to all the VM cores available. And afterwards, the VMs will scale down and deallocate automatically when no longer needed. Okay, so the build task is pretty much done at this point. And so the pipeline packs it up into a single zip file and then uploads it into a central storage container for other parts of the studio to consume. Extreme right of the mini-map, this time it's a producer reviewing that build that just got made in yet another Azure region. Now in your studio, you probably have a build dashboard that will do this, but for this demo, the producer will just use Azure Storage Explorer, which is the tool you see here, to pull down that build, and there's that new build with the right change list number. Under this operation, AZ Copy is a software tool that does the blazing fast transfer across Azure networks. Now the file is downloaded and unzipped, and the producer fires up the build, chooses the correct map, starts the match, and just like that, we see those holoboards in place. A code change made it from the developer in one region through source control and through a build pipeline in a central region, and then onto a producer in a third region for review. let's take a quick look at the pipeline's code in Azure DevOps. Now we'll breeze through this pipeline to give you a flavor of how things are set up to achieve what you just saw in the demo. First, the pipeline needs a build agent to do the work. In this case, it's asking for a VM that's been specifically set up for this task, something with a tag called dev, which has the value shooter game build. Next, we define all the variables we're using in this pipeline. We can do that here or in the variables panel off to the side, which has the added security of being able to obfuscate sensitive data like passwords, as you see here. Or you can even use Azure Key Vault to securely store and manage all your secrets at a larger scale. Next, some convenience tasks that use all the Perforce depot information to get a particular change list to sync to, and then actually sync the code to the workspace on the build agent. Then the actual build task comes next. Here you see a PowerShell task that takes as input an inline PowerShell script. This script basically kicks off the Unreal automation tool with all the parameters for it to do a full build. Now once the build is done, we want to tag the file name with some data like the date, time, and the CL number. So at the bottom of the highlighted section, we save that concatenated string into a pipeline variable called build tag. The two final tasks take care of compressing the output files into a single file for upload. Here, the archive files task uses the pipeline variable that was set in the previous task and appends that to the file name with the compression operation. Finally, the Azure file copy task uses AZCopy to move that build off the build agent and into a blob storage container for use downstream.
That's all we have time for this session, a really quick tour of Azure DevOps pipelines for Azure Cloud Game Production. Please visit aka.ms/Azure Game Production for documentation for this pipeline you saw in the session, available for you to try out. And please email us at azuregameproduction@microsoft.com. We'd love to hear from you. Thanks for taking the time to watch this demo, and have a great GDC 2022.